Good afternoon, everyone, and welcome to today's webinar. If at any point you have a question that you'd like to ask to the team, please use the Q&A tab to the bottom right of your screen. So today we're going to be talking through the Business Logic Attack Definition Framework, or BLADE, which has been developed by Netacea along with a community of cybersecurity experts, and is inspired by the MITRE ATT&CK framework. If throughout the webinar you think, oh, this is absolutely fascinating stuff, can't wait to hear more about it, and you happen to be attending RSA 2023, then please do pop along to see myself and the Netacea team at booth 1367, where you'll be able to learn more about the Blade and business logic attacks. Right, let's kick off with today's discussion. Firstly, I'd like to introduce today's panelists. My colleagues, Cyril Noel-Tagoe, who is Netacea's Principal Security Researcher, and Paulina Giaccali, who is Lead Data Analyst at Netacea. Cyril is an experienced information security professional. He spends his time researching, speaking, and writing about all things malicious bots and other cybersecurity topics. He is also a core contributor on the Blade Framework project, which we'll be talking about in detail today. Paulina works closely with Netacea's data science and threat research teams to develop new machine learning models for detecting anomalous web traffic. She is also co-founder of B-Sides Tirana, an international security conference. Today, Paulina is going to show us some real examples of bot behavior detected by the Netacea bot expert team and demonstrate how Netacea stays ahead of these threats. So why are we talking about business logic attacks and specifically Blade? Well, there are a range of attack frameworks, such as MITRE ATT&CK, that help security pros model and respond to traditional cyber attacks that are exploiting technology weaknesses. The business logic attacks, which include bot attacks like credential stuffing and scalping, which we see a lot in the news these days, do not have an equivalent framework. And as these attacks become more prevalent, it's clear that one is really needed. So frameworks enable cybersecurity pros to map common tactics and techniques for specific attacks. They also provide a consistent terminology. So some of you may notice that from one vendor to another, attacks are termed different. So for one business, it might be a credential stuffing attack. For others, it might be a blanket account takeover attack. So what Blade Framework aims to do is provide some consistency across that terminology to make things smoother between vendors and customers alike. The Blade Framework, as we're going to discuss today, began with the MITRE ATT&CK framework, was inspired by the MITRE ATT&CK framework. So over to you, Cyril, to talk a little bit about that.
Thanks, Danny. So the MITRE ATT&CK framework is a really useful tool for defenders. It's really important for defenders to understand exactly how adversaries are likely to attack them. And the MITRE ATT&CK provides this knowledge base of the tactics and techniques that adversaries may use, and it's based on real-world observations. So ATT&CK itself stands for adversarial tactics, techniques, and common knowledge. MITRE also has data sources for detection. So based on MITRE ATT&CK, you can see for a specific tactic, technique, or sub-technique, what data sources you need to actually detect that, and some techniques for mitigating against these threats, and some of the threat groups and the TTPs that they use. So MITRE ATT&CK it consists of 14 tactics, 193 techniques, and 401 sub-techniques. And the tactics are the goals that the adversary has during an attack. These are then split into the techniques, which are the means by which the adversary achieves these goals, and then sub-techniques further break this down. So what does this look like in practice? Well, here we have the MITRE ATT&CK matrix. At the top, going horizontally, you have the tactics listed, and then vertically going down, you've got the techniques. So if we take a tactic such as initial access, for example, which is an adversary trying to get into the network, a technique there might be phishing, and a sub-technique for that might be spear phishing through with an attachment, so sending a email with an attachment for someone to download and run, or spear phishing with a link, so sending an email with a link for the victim to click on.
So how big
Right.
of a problem bots are?
No, I just completely forgot to unmute myself there. Sorry, Paulina.
No worries.
So we now know a little bit more about MITRE attacks. Paulina, it'd be great to understand exactly how those attacks, how we deal with those attacks.
It depends on the data stream and the business usually. We see malicious traffic varying from 20% to 95%. In the top graph, I have shared a credential stuffing attack that lasted for around 2 days, and then they left and they came back at some point. As we can see from the graph, it has been 100% mitigated by the service we provide. And in the bottom graph, we can see the top 10 countries associated with the malicious users. It was highly distributed in terms of the users. We can see there were 143,000 plus users involved in the attack. More than 1,000 clients were involved, 163 user agents or desktop browsers in this case, 310 internet service providers and data centers, and 61 countries were involved. It's usually we'll see like very distributed attacks and like coming from residential proxy networks as well, which makes the level of sophistication even higher. Over to you, Cyril.
Thanks, Paulina. So MITRE is great, but it doesn't really apply to business logic attacks, the kind of attacks that Paulina was just showing there. So at Netacea, when we started trying to apply MITRE to business logic attacks and found it didn't work, and we ended up creating what we call the BLADE framework, which is the business logic attack definition framework. And this is a MITRE-style knowledge base of the tactics and techniques used for business logic attacks. And we wanted to make it feel familiar to people who are familiar with MITRE. So we've tried to keep terminology the same as much as possible. We have made a few changes there. We have 6 phases, which are the stages that a business logic attack goes through. Then we have the tactics and techniques under those. So let's kind of look through this. So as I said, there are 6 phases in BLADE, and these are the distinct stages that a business logic attack may progress through. It does not need to go through all 6 phases, but these are the 6 phases it can go through. From resource development, where an adversary is going to try and acquire or develop the resources necessary for the attack, through reconnaissance, defense bypass, where the adversary might try to overcome any defensive measures in place, through attack execution and actions on the objective, through to post-attack, where the adversary may try to monetize the proceeds of the attack. Now, these phases can then be broken down into tactics. So there's 24 tactics, and these are the strategies employed by adversaries during specific phases. So, for example, as part of the resource development phase, an attacker may acquire credentials. Now, this again can be broken down further into techniques, for example, how the attacker acquires credentials. But the real power of the BLADE framework is in the kill chains. Now, kill chains have been quite an important tool in cybersecurity since the Lockheed Martin cyber kill chain in 2011, which kind of broke the attacker lifecycle into 7 steps. And the key here with a kill chain is that if you can stop the adversary at any stage of the kill chain, you break the chain. So you've got Lockheed Martin said that you kind of got 7 opportunities to stop an attacker, kind of move the odds slightly back into the defender's favor. And with the BLADE framework, we have pre-made kill chains for common business logic attacks, and you can also use the framework to create your own kill chains. Let's take credential stuffing as an example. So credential stuffing is an attack where a bot is used to test previously leaked credentials. These are typically username and password pairs or combinations or combos. And these are used to, they're trying to determine if any of these are valid on a different website. So they're going to essentially stuff these credentials against the login path and see which of them stick. So here we've got a kill chain for credential stuff and bots. And as you can see, the attack goes through all 6 phases. So starting with the resource development phase, the attacker is going to want to acquire credentials. Now they can do this by getting a combo list. So that's a dump of username and password pairs or combinations from a hacker forum, as we've shown in this screenshot. They'll also need to develop or acquire a tool. Now, OpenBullet is the cyber criminals tool of choice for credential stuffing, and they can get this from GitHub. Then they'll need to tell the tool, so OpenBullet in this case, how to actually attack their target sites. Now, they might need to perform some reconnaissance on their target and build a configuration for OpenBullet, or most likely they'll just download a pre-made one from a hacker forum, again, as shown in the screenshot. And coming into the kind of defense bypass phase, if the attacker launched an attack from their own IP address, it'll be very easy for defenders to see and block. So to prevent this, they typically route their requests through a proxy network. And these days, they're more likely to use a residential proxy network where every login request is going to look like it's coming from a normal residential IP address. They may also try and bypass defenses such as captures. Now, bots are very good at solving captures. And they'll either do this through machine learning, so kind of image classification models, and solve it automatically, or they can even outsource it to human capture farms where they have hundreds and thousands of people just waiting to solve the capture for the bot and send it back to the bot so the bot can continue its task. Now, Paulina, how do we deal with capture bypass here in Netacea?
So as you said, Cyril, bad bots are using AI to solve the captcha challenges. On the other side, we are using machine learning models to detect bots bypassing captcha. So one of the features we use is called time to pass captcha. Basically, we do an estimation of the time to pass captcha, either if you are a human or a bot. Usually it takes more time to pass captcha if you are a bot, but it might also take less time to bypass captcha for some other bots. One of the captcha abuse models that we have and will predict if you are a bot bypassing, we'll do that based on the distribution that it takes to pass captcha. So basically, what we will do is we will model and evaluate the distribution of some humans that are bypassing captcha, let's say, by doing some tests or either relying on false positives, which usually are in a low level. And then compare this with what we know that are bad bots that are bypassing captcha. And then we tested together the different distributions and we set some dynamic thresholds. And based on those thresholds, we identify basically which one is a boot cluster to hard block in this case, and it coming from malicious sources. Over to you, Cyril, again.
Thanks, Paulina. So now the adversary has developed their resources, they've performed some reconnaissance, and they've bypassed defenses. They're ready to launch their attack. And the best way to show this is by actually launching our own credential stuff and attack. So I am going to set up a demo here. Okay, so we have Cyber Cyril's security blog, which is the most secure site ever. This is going to be the target of our credential stuff and attack. And we are going to OpenBullet 2, so the second version of OpenBullet, the cyber criminals credential stuffing tool of choice. So the first thing we're going to do here is we're going to add our combo list. So the attacker would have acquired some credentials, and they're going to add these to the bot. So I've got my combo 10K here. So this is just 10,000 username and passwords. Attackers can get hundreds of thousands of, and even sometimes millions of username and passwords from hacker forums. So this is quite a small combo list in comparison. But we'll upload this here, and I'm just going to change the type of it to credentials, so OpenBullet knows that we're using credentials. Next thing we need is a actual config for OpenBullet to know how to attack Cyril security blog. So again, we're going to simulate that the attacker has downloaded one of these from a hacker forum and just going to upload it here. So we've got Cyril config. And that's all worked. Now with that in place, we're ready to run our bot. So if we create a new job here, we're going to select a multi-run. A multi-run just basically means we're going to have multiple bots running our code. And we're going to have 10 bots here. This is just the amount of concurrency. So the more bots here, the quicker it goes, depending on how much infrastructure you have. This is just running off my laptop, so we'll see how much it goes. I'm going to select the config, and I'm going to select my word list. We can see some of the credentials here. These are just the first 10. We've got 10,000 of these in that list. Now, that's the resource development and the reconnaissance phases essentially done. If we come to the defense bypass phase, if we're going to use proxies, we could just add them here into this group, some proxy sources. In this case, we're not going to add any proxies because we're just running this locally. But in a real world attack, the attacker could add proxies there. We're happy with it just output into the database. Sometimes the attacker can output it to their own Discord, Telegram, or custom webhooks as well. So now all this ready, we're just going to create, oh, this has gone back to 1. Let's make that back 10. And we are going to create a job. So we're going to press start here. It's going to take a while to think about it, and it should then start running. So let's just give it a few moments. There we go. So this is now running, and it's taken one by one each of those credential pairs and testing it against the login path of Cyril security blog. Now, whilst that's running, I'll show you kind of what this config is actually set to do. So this is quite a simple config, but it shows some of the parts of the Blade framework quite well. So the first thing this config is doing is randomizing the user agents. So this makes it look like different devices are making each of these requests, which makes it harder for people to tie it all back to the same threat actor. And so this is part of the defense bypass. It's then making the login request. So this is the attack execution phase. Here we are taking a username and password from our combo list, and we're sending that to the login portal, and we're also using the custom user agent we've created here, and we're adding that into the headers. We're then capturing the username and the password so that we can later sell this information. And then we've got a key check. So here we're trying to see if our login attempt was successful. So if we get 302 a redirect, we know our login attempt was successful. If we get a 200 and a message back saying that the user is not registered on the site, then we know that our login attempt failed, but also there's no user on that site. And if we get a 200 back and the message says the password entered was incorrect, again, we know we failed, but we also know that that username is valid on the site. And that could be useful to the attacker who might want to perform some phishing or social engineering to get those credentials. So that's our attack execution. And then actions on objective is when the attacker wants to, in the case of credential stuff, and exfiltrate data from the site. So in this case, we're going to the profile page, again, sending that custom user agent, and then we're capturing the email address. So this is data, this is non-public data that we're pulling back from the website. So imagine if this was a financial application or maybe a retail application where the attacker might be bringing back something like an account balance or a gift card balance, which will make the account they're trying to sell afterwards more valuable. If we wanted to add something like a capture bypass, it would be as easy as adding a block here from the stack, clicking on captures, choosing which type of capture it is. I'm going to use H capture as an example because that's where my mouse landed. add the site key and the site URL, which they can find from the HTML of the site. And they'll just need an API key for a capture solving service. And that is how easy it is for them to solve captures. In this case, the site doesn't have a capture, so we don't need to do this. Let's go back to our jobs and see how this is running. So we are about 75% done. We are doing roughly 2,000 a minute. Again, this is just running on my laptop, running on dedicated server. This will go a lot quicker. But we're already getting some hits back. So let's have a look at them. So on the right, we can see the hits. The first one we've got is Fred, who's got the very secure password or password with some character substitutions. And we can see that here that this was a kind of a Chrome AT user agent from a Apple device. We've got Fred's username and password, and then Fred's email address we've been able to pull back from the site. If we look again at the next one, we've got the admin. Now, as an attacker, anytime you get admin credentials, you're very happy. This one's come from again a different Apple device here. And then if we go on, we've got some further hits down here. Now, to prove that these hits are actually real, I am going to use the admin credentials which we've just got to log into the site and prove that these email addresses have actually been pulled back from the site. So I'm going to go to hits view, which provides another view of the hits we have here. And I am going to take our admin one here. First, I'm going to get our login portal. And I'm going to copy and paste these because I cannot remember and type that quite secure admin password. And there we go. We've been able to log in. If I go into users now, we can see, well, there's my email address if anyone wants to email me afterwards, after this webinar. But we've got Fred's email address there, fred@privatemail.com, which if I just go back to our jobs and show, that's fred@privatemail.com. Got Warden at hide my email and Lindy at thisisprivate.com. And again, these are being pulled back from the sites. So that is how a credential stuff and attack works. The final stage will be post-attack, where the attacker would package this information from their hits and sell this on. Okay.
Thank you, Cyril. Cyril represented a simulation of a bot attack through the Open Bullet tool. In this slide, we will analyze the complexity of the attack by the features we have created and see if there is any correlation between them. This attack is much more distributed in terms of the users. So they are generating more users compared to other sources, as it can be seen in the top graph as well. If we export from the legend the number of users, we see a correlation between other sources. We can't see a lot on the second turn, as in this case, they were using residential proxy networks, which associate with common data centers and other sources to sophisticate the level of the attack, basically. But in the first attempt, let's say, where they were attempting to attack the login endpoint, we can clearly see that correlation of the attack sources. And before the attack happened, we can see a very, let's say, seasonal and consistent traffic. And then we can see in the next slide, I have filtered only the mitigated traffic to show that we still see the same correlation across sources, and we don't block a lot out of the attack time range, which falls to a low number of false positives. So it's very important that we don't cause false positives in the customer APIs, including here web traffic and mobile app traffic as well, as that might block real people, and we don't want that But in this case, we, as I represented at the start of the webinar, like where I showed that we blocked 100% of this credential stuffing attack, it's very clear here that if we check the whole week, we'll see that we are blocking only during the attack time window, which is very important. Over to you, Danny or Cyril.
So, okay. So we've actually got a question come in for you, Cyril. So from Panos, he'd like to know, how long did it take to get this complex password?
Good question. I don't know.
ChatGPT? Well, no, seriously, that every time I see the credential stuffing demo, it is just the best way of illustrating how easy it is to execute these attacks. Thank you very much for that, Cyril. And for taking us through the real world application as well, Paulina. So now we're going to talk about scalping attack. And I think all of us have heard about scalping attack in some way, shape, or form in the news in recent weeks, months, whether it was from Taylor Swift's Eras tour, or if you were trying to get hold of some Eurovision tickets a couple of weeks ago. It's or even PlayStation consoles or NVIDIA cards, whatever you've been trying to get hold of, it's been low supply, high demand. In the last 5 or so years, it's likely that you've been affected by scalper bots. So Cyril is going to take us through a scalper bot's kill chain and apply the Blade framework to that kill chain. Because what the Blade framework tries to do, as well as thinking about terminology and bringing some consistency to the bot management industry, what we're trying to do is identify as early on in the attack as possible, the tactics and techniques that are being used by attackers, so that we can think about whether it's in the reconnaissance stage or the resource, even as early as the resource development stage. What is the attacker trying to achieve? If we can identify that intent, we can stop the attack before it becomes fraud. Over to you, Cyril.
Thanks, Danny. And that's a really important point you made there. So the scalper bot's kill chain, we've got 5 phases. So as I said earlier, it doesn't have to go through all 6 phases. With the scalper bot, it goes through 5 phases. And really, we want to stop the attack as early as possible in the chain. And the first phase for a scalper bot is going to be, again, resource development and credential acquisition. Now, in some cases, credential acquisition could be creating accounts to use for the scalper bot. So that might be something we see as fake account creation. And if we can stop at that phase, at that stage, then we stop actually the scalping attack from actually going on. In the reconnaissance phase, the scalper bot's going to look to try and either basically look at a specific company or a specific organization to scalp from, or a specific product. Or sometimes it might have a loose target. It might just be looking for things which are have a certain price or are under a certain price. So one of the things we've seen more recently is freebie bots, which look for any items which are heavily discounted and purchase those instead. The idea being that the buyer can now sell those on, and even if they sell them at RRP, they can still make a profit. So for the reconnaissance phase as well, you can typically have separate bots which are monitoring and scraping sites for that. And again, if you can stop it at that phase, then you prevent the scalping attack from actually happening. So Paulina, what does this look like in the data, and how do we apply models for this?
Thanks, Cyril. So scalper bot attacks are much quicker than the other attacks we see. In this case, this attack lasted for around 30 minutes, and it was very distributed in terms of the number of clients they were using, which goes above 200,000 in an hour, as we can see in the top graph. By excluding the number of clients, we see that they were using approximately 12,000 browsers, more than 10,000 to organizations, and 9,000 data centers to hop their traffic. As I said, they do the attack basically very quickly, and we'll see in the next slide the phases that they go through basically. So there are 3 phases, I'll say. We investigate from a data team's point of view. The first phase will be focused on account creation, account takeover, and product scraping, where bots monitor targeted websites, create accounts, and scrape products or any, content associated with products like the product's price or any other content. The second phase is the add to cart abuse, where bots hit the basket massively. And then the last one is checkout abuse, where bots hit checkout endpoints to do multiple purchases exceeding the limits. They might associate with the same malicious sources in all phases. And if that happens, it's easier to ensure protection. It's unlikely to happen, to be honest. If they change behavior and they rotate to new sources in the next phases, then we'll need to have models enabled basically in each phase. As if we have one model enabled in the first phase and then change behavior in the second phase or in the third phase, that model will not be able to protect the whole journey, let's say. So we need to make sure that we have set it up basically models for each phase. So we make sure that this attack gets blocked. As we showed before, they hit the website for very quickly, like up to 30 minutes. So we need to be very active. Regarding the value of Blade, we use Blade framework to map other bot attacks, like fake account creation or product scraping, where, as it can be seen in these 2 graphs, we are blocking 79% of the traffic in the top graph for fake account creation and 94% of malicious sources in the second graph for scraping. I would say that Blade, it's very helpful to identify new use cases when with PLC as well, and link together the strategy of bot attacks. For instance, recently we had a customer that came to us with scraping as a problem. And based on the kill chain and intent analytics investigation that we did, we identified that they were getting harm in the add to C, which is like, adding stuff into the basket, and checkout payment endpoints, which happen from scalper bots being active in some limited products. But yeah, we can also mention other attacks, but these are, I'll say, the second most seen attacks coming after credential stuffing, account takeover, and scalping. Basically, we have fake account creation, product scraping, and we have some more other, use cases as well, which are more specific. But in general, these are the use cases that we see more often. Over to you, Danny.
Sorry, I'm just so engrossed. Just going to unmute myself again. Thanks, Paulina. What is really interesting is hearing that real world application and how you're able to use and combine it with intent analytics actually as well. I think that's something that's been touched on throughout this webinar, but how you've combined Blade and intent analytics to understand user behavior is really interesting. So Sarah, you're now going to chat through with us of some of our customer case studies and talk about how Blade has been applied to them and what it has been able to achieve.
Yeah, thanks, Danny. So we've got 4 use cases here just to give a little flavor of how Blade has been used by organizations and the value it's brought to them. So the first one is an international fashion retailer. So international fashion retailers, typically you have use cases ranging from credential stuffing to scalping. So both the use cases we've kind of gone through today would be valid for that type of company. And they really wanted to understand the types of business logic attacks that they might be susceptible to, but also bring everyone on the same page. So whether that's the digital teams, marketing teams, security teams, to understand these and all speak the same language, all be on the same page. And that's really what the Blade framework allowed them to do. It also gave them a better understanding of their risk, allowing them to understand the likelihood and the impact of different techniques. as they go through the framework and understand what's more likely to be used against them. And a really useful thing for them was actually also a lessons learned piece. So looking back over the kill chain and saying that if we identified an attack at this stage, we know that it must have passed through these other stages before. Can we adapt our detection model so that we can detect it earlier on next time and have less impact? Because again, the earlier you detect an attack and stop an attack in its life cycle, the less impact it has on your organization. The second use case was a major healthcare provider during the pandemic. Now, during the pandemic, all healthcare providers were under increased scrutiny and stress and had lack of resources. But this provider in particular was looking at providing some digital services. And they needed to do some threat modeling. They needed to understand how those digital services might be attacked. And the Blade framework provided a useful tool for them to be able to understand what bot attacks and business logic attacks were likely against those digital services and put in the right defenses. Use case 3 was a big 4 supermarket chain. They used the Blade framework to understand how to detect specific attacks. So they need to know exactly what to look for specific attack techniques. And they could also map the kill chain, so map the attack through the kill chain and understand how to stop the attacks. And then finally, telecoms CISO used the Blade framework for mitigation purposes, but this was really a prioritization play here. So most security teams don't have an unlimited budget. And if you do work for a security team that has an unlimited budget, please let me know and I will come and check it out because that sounds awesome. But generally, you've got to prioritize your resources. And knowing that specific attacks go through specific phases, if you can look at kind of your whole estate and say, okay, we have these many attacks and they all go through a certain phase, let's focus our mitigation efforts on that phase. And not only do we stop the attacks earlier, but we can put less mitigation effort and still have a stronger effect on mitigating a wider range of attacks. So that's what the telecom CISO was able to use Blade for. Back to you, Danny.
Thanks. And look at me, managed to unmute myself in time, concentrating on what I'm doing instead of what you're saying. So thank you both very much for going through that today. And I think applying the Blade framework to two of the most commonly observed attacks that we see across the bot industry, from credential stuffing to scalping. And there has been an awful lot to digest about Blade. It has been very much a whistle-stop tour. So I just want to accentuate some of the key points that have been made today. So the Blade is designed to help security professionals to understand bot attacks. And that is by mapping the attacks across, by mapping attacks to the Blade framework, we can save money, prevent outages by preempting those phases. So as Cyril said earlier, we look at those early phase tactics and techniques, and then we try and prevent the attacks from getting even further down the line. So apart from that, we obviously also want to create some consistency in language and approach across the bot landscape to better equip both businesses and vendors to identify attacks and basically get to start to understand what is actually going on with their business, what's impacting their customers, and how can they help to prevent attacks and prevent fraud before they're carried out. So we also have another two questions that have come in from the audience that I'd like to put to our excellent panel today. So from Anissa, she would like to know, how does the Blade framework handle false positives such as legitimate users who may exhibit behavior similar to scalp bots?
I'll take that one, Danny. Thanks, Anissa. So I think Blade framework itself, doesn't look after the false positives. We as a business, Netacea has other sources, let's say, or tools that will look after false positives. So in the operational side, like when we have like a model deployed for one of the use cases, basically, in this case, is it for scalper bots? Yeah, for scalper bots, we will do like a review at the performance measure of the model and see how much might be the false positives and the errors that the model will bring. So usually, let's say we use unsupervised learning machines and like supervised learning machine, both of them or a combination of them, and also anomaly detection. So I would say that it's always challenging to measure false positives. If you have CAPTCHA implemented as a service, that will be a very, let's say, good collaboration between us and the customer, as we can see how the users basically will solve the CAPTCHA challenges, how quickly, and as we explained before, we do the CAPTCHA bypass measurements as well. What we do in the verification of the models that have been deployed, we make sure we have this as low as possible, which usually needs to be 0.5% or lower than 1%. As I said, the CAPTCHA implemented, it's something that it helps a lot. But we also, in the other side, we also have like residential proxy networks that they behave as normal users. And there are other features in the models, like one of them, supervised machine learning models, for example, it will clusters based on the behavior that the users do. So it's very rare that, let's say, a human and a bot, they will do the same journey within the same time. Even so, if they can, I mean, they might do it in purpose, but let's say one of the methods, which is called time series clustering, basically it will cluster together users based on the behavior they do over time. So if a human and a bot doing the same behavior over time, it's very rare. And I hope that answers your question, Anissa. Thank you.
Anissa, if you'd like to know any more, please do feel free to get in touch with us. But yeah, hopefully that was helpful. There's also a lot of resources on the Netacea website that should be able to help answer that question in more detail. Thank you very much, Paulina, for answering that for us. So I think this might be another Paulina question. So this has come in from Alec, and he would like to know, how early on do you start mapping attacks to the blade? Is it before you start working with the clients, or is it once you've already got the project underway?
So we start, I mean, once we onboard a customer, let's say, or a POC customer, that's, I think, the initial phase when we start the investigation. So let's say if we are in a POC with the customer, the first thing we'll do is basically we'll run like an initial threat research report, which is collaboration between threat research team and data analytics team. And based on that report, we investigate the kill chain of this customer, their API, if they have like mobile app traffic, web app traffic, what kind of traffic are we ingesting? Basically, what might be the potential use cases that they might have. And this is something that we map from the Blade framework. So yeah, once we have ingested the data, basically we start with the investigation.
Great. Thank you very much. It's helpful to understand a little bit more about how Blade is used in the POC process. Okay, so let's wrap up today's extremely interesting session. Again, thank you to Paulina and to Cyril for taking us through everything today. It's been great to hear your expertise and insights, as well as obviously Cyril taking us through that demonstration. If you'd like to find out more about the Blade framework, then please do feel free to head to the bladeframework.org website. It is a completely free open source resource. Open source resource is a bit of a tongue twister. And if you'd like to download any of the resources, useful resources that are available on there, or if you'd like to join the community itself, then please do so via the website. Or if you'd just like to contact us and ask us any questions. So we have a number of contributors in the community, including 2 bot management vendors, big 5 tech businesses, leading retailers, major energy supplier, and a healthcare provider. So just to emphasize that this is not, while Netacea is kind of developed it from the start and laid the foundations. It is very much a community-driven piece of work. The framework itself had taken on a life of its own. It's exactly the direction we want it to go. So yeah, please do feel free to head to the website and get in touch with us if you have any further questions about today's session or about the blade. And just to reiterate that we are going to be at RSA in the next month. So if you are going to be there as well and you'd like to come and say hello, please do visit us at booth 1367 and you'll be able to meet a number of our team. I hope you all enjoyed today's session and thank you for joining us.
Thank you, everyone.
Yeah, thanks.